Yo, let's get this show started. And thank you, Derek, with the donation. It really means a lot. Um, Thanks for streaming so consistently. I love watching these. Thank you. I love making these, and hopefully, I will keep going far, far into the future. And you also said that you played through Viva Pinata. Uh, how did you like it? Okay, so when it comes to what we're currently working on here, we're currently working on getting the water to look good. And I haven't showed the look I'm aiming for just yet. I really should in the future. Truth be told, I don't have. It's all in my head right now. But I know that I want my water in this game to be diverse. So a shallow river will look way different than a deep lake. And when it comes to water, it's usually built up of many different separate effects that all works together to make the beautiful water we see in games these days. And we're talking about distortion, refraction, reflection, blurring, color based on depth, colorizing based on view angle, and much, much, much more. And it's these separate things we're trying to implement right now, and actually hit kind of a roadblock, to be honest with you. And the roadblock, well, that's how development is, I would say, at least when you're at the boundaries, which I think we kinda are. But so when it comes to blurring, doing a simple blur, like blurring everything uniform that is behind an object, is quite straightforward, and we have that in place. What we want to do now is blur based on depth, because the deeper in the water we are, the more we want to blur. So blur less at the surface and a lot at the bottom. And this is extremely hard to get right because you have problems like bleeding and stuff like that. And yesterday we tried multiple different approaches, got a little bit of a better result, and I'm at the point where I'm gonna try some new things today when it comes to blurring on different depths. But if we can't make it work today, I'm gonna postpone this task until later and just settle with the effect we have right now. So that's what we're gonna do today. Derek, it was great. Viva Pinata, that is. Much easier as an adult than it was when I was young. I didn't 100%, but I did unlock the credits by getting the Ultimate Gardener title. Nice. Oh yeah, I reckon it could be quite a lot easier these days. I played it also when I was quite young, but I just loved, being in the garden, fiddling with the trees, fiddling with the pinatas, and that's the feeling I want to get in this game. But of course, a little bit more complex. But we'll see. Yes, so let's see what we have now when it comes to the blurring effect. And I mean, it's quite okay. We have some issues here with the outline, but I mean, this is acceptable at low blur level. But as soon as we make this, it's still, It's still acceptable. At 10 we start seeing artifacts. I'm not enjoying that much. But like, if I can't improve upon this today, we're gonna settle on this and move on to other stuff. This will work for now. Would also like to make it a little bit more performant, but okay. Derek, I got it as like a 2-in-1 game case with Banjo-Kazooie Nuts and Bolts, also great game. Yeah, Banjo-Kazooie Nuts and Bolts I never played. I played a demo of it, but not much more than that. Maybe I should give it a try again. I love the old Rare games, actually. Okay, so this is the solution that works-ish. So what we're gonna try today is, let me just open my notepad and we can see if I can try and explain what we're doing, or what I want to do today, or the approach I want to try today, because I've been thinking about this a tiny bit, doing some research as well. And just to mention, like, if you want to get a very good depth of field effect, which this basically is in some ways, you usually have to do add a separate pass, and I want to avoid that for now. Let's see here, documents, notes. Derek, I also love the old Rare games. Grew up with Donkey Kong Country on this Super Nintendo. Oh yeah, I remember that one. It was great. I think my favorite Rare game from back in the day is Viva Pinata, of course. But apart from that, I'm also a very, very big fan of Banjo-Kazooie and Banjo-Tooie. Fucking great games. Okay, so what we're doing now is, if we're gonna blur, if we're blurring a pixel, we look at the depth value of that pixel. So let's say this one, and then we look at the the depth value, and then we base, let's see here, how can I do this? Roboto. Base, let's go 26 maybe. Base kernel size on depth value. That's pretty much what we're doing right now, which means that neighboring pixel has different kernel sizes based on the depth they have. But what I think we're gonna do is we're gonna have the same kernel size at all times. So let's say that we do, how do I want to do this? So we want to have the same kernel for each pixel, but we base the weights. So we did this and we want to do this, but we base the weights here on distance from center, and depth. I don't know if these visualizations are the best, but base use same kernel size but base weights of kernel on depth values and distance to center. Basically what we want to do is we want to do a depth of field or a proper depth of field effect, but we want to do it the other way around. So if we would have had something that looks like this, if we would have this kernel instead, so we have this pixel and we want to blur the values here, what we do then is we check this neighbor, we check the depth, or the COC I think it's called in depth of field, and we see if does this pixel have any effect on this pixel. If so, accumulate the color from it, and then we do it for each pixel. And that's actually exactly what we want to do. Oh yeah, but what I mean by the other way around is usually you loop through each pixel. So for this pixel, you check all the pixels, neighboring pixels, and you spread the color from this one to those pixels. Then you take this pixel and you spread the color from those to all the neighboring pixels, and then this one, and so on and so on. We want to do it the other way around, so we take a pixel and we check all its neighbors and see how much color they get from their neighbors. And we want to base it on depth. So I really wish I could zoom in more here. It's very similar to what we have done. Definitely. But I just want to take it one step further, I guess. So if we're going to calculate this value, we have a fixed kernel size. So we start loop. Let's say that our fixed kernel size is 3 times 3, which is quite small. And I just have to, as a side note as well, I'm a little bit afraid of the fact that this is going to be hard to implement with the MIP solution we have, or we might get some problems with it, but it's worth a try. So if we have this pixel, we're going to calculate, let's do one of these and do one, calculate water depth at P. So this pixel, how far from the water surface is it? And then we want to calculate base weight, I think. Calculate base weight based on water depth. So pretty much given how deep this one is, how blurred do we want it, and that's going to be the base weight for all its neighbors. So that is very similar to what we do right now. For each pixel, or for each neighbor, n, calculate weight as something like calculate weight based on base weight WB, distance from center D maybe, and neighbor depth. Base weight and what do we want to do? So weight is going to be equal to, I wonder if we want to do D times weight base plus neighbor depth. Yeah, we're gonna have to calculate neighbor depth as well. Or actually, no, I think we want to do D in some way plus dn maybe. Distance from center, well, let's rename that one C. Something like this. This is a very rough outline. But basically, we have a base weight based on how blurred this one should be. How deep is this one? And when we take a neighbor, we want to know how much of the color of the neighbor spreads to this pixel. And if it's close to the pixel, we're going to get more color. And also, if this one has a similar depth as this one, we're going to get more. So let's call this one PD at P. So it's actually going to be we're going to normalize C in some way. But here we do dn minus PD. So yeah, we actually want to call this one ND, I think. And maybe even abs here. And then we want to bring this into a 0 to 1 limit as well. I'm wondering if we want to make, do we want to make a difference between between depth that is closer to the camera. So like if we do we want to make a difference between the spread from something that is closer to the camera compared to something that is further away from the camera? I guess we're gonna have to find out. But we have done something similar here, but not exactly. So water depth at pixel is scene water depth, I think. Pixel scene depth and pixel depth. Yes, so this is scene water depth. And then we have to calculate it here as well. But that's harder though. Because we don't actually have the water. I don't think we have the water surface depth at this point. So the question is, do we want to use this one? So the one for the center pixel? Yeah, maybe. We can try it. So let's do float water depth is equal to depth minus pixel depth. I think we're going to add a continue here as well. So like for instance, if water depth is less than 0, so pixel depth is bigger than this one, then we just do continue. But otherwise, we're gonna do some calculations here. We're gonna do, so now we have neighbor water depth and we have center water depth, and we want to do float depth diff, or let's call it water depth difference, is equal to abs water depth minus scene water depth. So we're going to base it based on this. So this is a value that could be between where we are working in linear eye depth, so this one could be something between, like worst case scenario, it could probably be between minus far plane and positive far plane. So quite big of a value. And what we want to do is float water, let's see here, weight, saturate, inverse lerp between, here we're going to do some values we choose ourselves, much like we do here. So we're going to do water blur margin X, water blur margin Y. I wonder if we just want to go from 0 here actually. 0. Yeah, I think so. X. Water depth difference. So here we get a value between 0 and 1. I think we want to, we want it to be 0. Let's also do float base weight. We can probably calculate this one much like outside of the for loops, but for now we're going to keep this one here. And base weight, I said it would be dependent on the depth of yeah, base weight is gonna be, we're gonna do something similar here. We're gonna do inverse slurp, and here we do 0 and water blur margin X. So on this one we do Y. And it's just gonna be scene water depth, I think. So if this one is closer to 0, we get 0 here, and then we probably want to do yeah, for now we're also gonna do this. So we do we do scene color here. Color count is 1. And then we do, let's just do one of these checks here. If X is equal to 0 and Y is equal to 0, continue. So we add the center pixel here, color count 1. Return color just divided by color count. Okay. So for now we should just be getting, yeah, the color itself. That's great. Oh, base weight. We actually want to make this one, we want it to depend on water blur, water depth bounds, I think. So water blur, water depth bounds dot X and dot Y. So that's the base weight. So the closer scene water depth, the closer to this one, we just do 0. Closer to this one, bigger. Okay. So the bigger the scene water depth, the closer to this one we are. But I think that's good. Yo, what's up, Mr. Quote? Hello, did you remember me? India, if I remember correctly. question here is 0.9, 0.9. And then I also want a distance from center, so the further away we are on these, the less of an effect I want. Distance weight is equal to inverse lerp between kernel size one minus, and then we do 0 kernel size I think we want to do square root of pow x2 plus pow y2. So if this one is 0, we get 0, so then we get 1, yes, something like this. And then we do color count, or actually float total weight. Do I just want to add them? No, I think we want to do distance weight times base weight plus weight. And then we want to do saturate on all of this, so it should only be between 0 and 1. And then we do color plus equals to total weight times, and we sample the color here, and color count plus equals to total weight. In fact, now we have total weight down here. That's good. And then we do color count. Okay, so what do we have here now? What can we try first? So let's try base weight first. So water blur, water depth bounds, water blur, water depth bounds. Actually, distance weight times yeah, then we want to change kernel size here as well. Okay, so we're getting blur everywhere. We're getting a uniform blur everywhere. And let's see. So all of these variables are 0. So we have 0 here, 0 here, 0 here. Base weight do float total. Oh, actually we don't need to. Let's keep this one and just do total weight is equal to base weight. Let's make this one work first. Okay, so base weight, saturate, scene water. Ah, yeah. It's no, it's scene water depth we want to use here. If it's 0, I was hoping this one to be 0, so this one is 0. Why aren't we getting 0 here on base weight? Scene water depth, inverse lerp, X and Y. Water blur, water depth bounds, it should be this one. Okay, -5, 1, 2, 3. This one is 0, this one is 5, scene water depth. Is this one negative? This one should always be... Actually, it's just scene water depth, which is pixel scene depth minus pixel depth. Yeah, this one should be positive. Pixel scene depth. Yeah, this one is bigger if we're underneath water. So this one is positive. Yeah, if we're in front of water, this one is going to be negative. So we're going to get this one. Then we saturate it. So that's good. But is this one all... Oh, are we working with 10? No, we aren't. 500. Are we working with as big values as that? I don't know. 500. Okay, this one seems to be very big. Why? Scene water depth. I don't buy it. Why is it? Why is it so damn big? Let's move this one here for now and return base weight. Yeah, that's not what I want to see. One sec. There we go. 2, 3. Okay, 4, 5, 6, 7, 8, 9, 10. Okay, this is pretty good. So here we don't blur anything. Here we blur quite a lot. Okay, this is good. Base weight is good. But when we do, then we set it to total weight. Oh. Okay. Are we going? Okay, so we have a base weight. Then we set total weight to base weight. Down here it's big, up here it's small. And then we add it here. What I wonder though, why are we getting so much blur here? Okay, I get it. Because this one, but okay, I get it. Yeah, I think this is good. I think it's best to see it here. Yeah, we blur more and more and more. Okay. Okay, so I think that weight works as it should. And then let's try. So total weight is equal to base weight. Let's do plus weight here. Saturate. I wonder if I would probably want to multiply these, honestly. So this is water depth difference. So if the difference is small, we do 0. So we want to do 1 minus. So if it's small, we do 1 minus. If it's big, we do closer to 0. Okay, so we multiply these two. Total weight, and let's see what we get. Water blur margin Y, let's go X. So now we have water blur margin, we have 0 here, which means that we will always get 0 here, or always 1. It seems like. So if we put this one as at 1, we get blurring here. We can see we get this type of blurring here. That's pretty cool. Very similar to what we had yesterday, I think. still think this looks a little bit better than yesterday. Still got some bleeding here, definitely. Okay, let's see what happens if we take this into account as well, this one. So if this one is small, we're doing 0, we're getting 1. If this one is big, we're getting close to 1. Okay. And then we do distance weight multiplied here as well. Okay. Yeah, this is probably the best result yet. I would say, I think so. Let's see if we can make this work with the outlines as well, but the problem here is gonna be how to optimize it later on, because if we do this, we have a blur size of 10. It's extremely slow, and previously we wanted to increase the size here by reading from a downsampled texture instead, but we're not going to be able to do that, or not as easy as we previously did, at least. I wonder what would happen if we did so we do this kernel size, we add a, let's try this kernel size, and here we do kernel step size. Hopefully this one will be, I can clarify this one soon. Kernel step size. do I want to do it like this? Let's try. Int kernel step size. Yo, what's up, Dev Sorcerer? Hope you had a wonderful stream. And thank you for the raid. So what I'm thinking of doing here is kernel size, blur kernel size. I wonder what will happen if we do this. Let's comment this one out and do int kernel size is equal to something and int kernel step. So kernel size, here we do kernel size divided by kernel step size, and here we do kernel size modulus kernel step size. So kernel step size, yeah. I wonder what will happen if let's save it a bit by doing max. Kernel size, it's this one, and kernel step is this one. So, fuck, does this actually work? What the fuck? Yeah, it looks to be working. Dev Sorcerer, hello, what are we doing for today? We're fighting with blurring again. One, why we're not getting anything here? 2, 3, 4. Oh fuck, am I not doing this entirely correctly? Let's see. But it looks to be working pretty good, honestly. So now we get a lot of blur and we're still at 200 FPS-ish. It's beautiful, but let's see here. Kernel size. Kernel step size is 3, so if this one is 9, we have 9 divided by 3, we get 3. No. Kernel size should be... I think we want to flip these two. Does that make sense? So kernel size, if it's 9 and we have a kernel step size of 3, we get 3 here. So we read from this one. And for now, let's take this one and we do kernel size is 0. Let's see if this works. No. Oh yeah, because we don't read. Kernel size is 1. 1, 2. Do we want to do a round here? Whatever that is. We're just going one layer up. What is this? Kernel size. So let's say we do 10 here. We do 10 here. Kernel step size is 3. 10 divided by 3 is, what is it? 3 times, or 3 point something. This one should be 3, but why isn't it? Kernel step, textile size. Oh, whoa. Oh. Textile size, kernel step. Okay. 3. Oh, yeah. Plus 1 here. Yeah, we don't want to do round here. It comes with some negative effects, but yeah. But I still want to know, why are we getting... So like at 0, we should have, this one is 0. Zero, 3, we get 0 plus 1. This one I don't like. Kernel size 1. So at 1, we should be getting some, let's see, kernel step. Wanna rename this one, I think. Kernel size, kernel step size. At 1, we should be getting 1, right? So 1, 3, we should be getting 1 here. But we're not. 1, 2, at 2 we're getting something. One point 23. Why are we getting the first blur at 1.5? That doesn't make much sense, does it? Okay, is it because this one is an integer? Nah, I don't think so. Okay, here we go. I want to try. Let's just do kernel step now. Is equal to 0. So 0, 1, 2, 3. That's when we get the next MIP. Beautiful. 4, 5, 6 is where we get the next one. Beautiful. 7, 8, 9 is where we get the third one, right? Okay, beautiful. Yo, what's up, Fabic? How are you doing today? Okay, this is good. So kernel step works. Now I just want to see if we can make this one work as well. Kernel size. So we do 0. One, 2. Why are we getting at 2? Fabric just woke up. Oh, that's still pretty early, isn't it? I'm doing fine. I think we're testing one new approach today with this blurring. The last try for this time, and I have high hopes. So, but why can't I get this one to work? Kernel size. Kernel size modulus kernel step size. So if this one is 1 and this one is 3, we should be getting 1, right? But for some reason we're not. Am I misunderstanding modulus on the shader? Because we're not seeing any blur here, right? Let's see here. 0, 1. No. 0, 2, 3. Yeah, 3 doesn't give anything, as it shouldn't. 4 gives, but 1 doesn't. 6, 7, 8. Fabic, I love the attention to detail you're putting in your work. Keep it up. Thank you, appreciate it. Yes, sometimes it can be a bit much, but we'll see. Modulus HLSL. Modulo Fmod. One, 2, reminder of 1 divided by 2, which is 1. Yeah, I don't even know why I'm reading this again. Oh, the modulus operator truncates a fractional reminder when using integers. Oh, reminder of 1. What the fuck? So we definitely don't want to use floats. But let's see here. Maybe kernel size, kernel step size. Oh, int. Let's see here now. 1. Fuck, why doesn't it work? 2, 3, 4, 5, 6. This is weird. One modulus 3 should be 1. 2 modulus 3 should be 2. 3 modulus 3 should be 0. Zero. 1. Okay, we're actually getting 1. That's good. 2, 3. Okay. This seems to work, so... Okay. What am I missing then? Kernel size. So if it's 1, minus 1, 1, minus 1, 1. Ooh, I might know. Texel size is kernel step. Nah. So it should be 2 to the power of 0. So texel size should be, so this should be 1 times this. It should be okay. Extremely old. Comment. Let's double check POW HLSL. If X is power, yeah, it's bigger than 0, and this one is equal to 0, then we get 1, so it should be okay. Fuck. Like, I should be seeing 1. I should be seeing a little bit of a blur here right now. Like, definitely. Unless. Okay, 1, 2, 3. Okay. So distance weight, base weight, or weight gets fucked up. based on this one. Kernel size, I don't see how it happens here. This one, yes. So I think we want to do kernel size here. Or actually, no. We want to do, what do we want to do? So it's distance weight here. So it's like in a circular fashion, how the further away we move from the center, the less we want the neighbor colors to spread. But like, what do we want to base this one on? Do we want to do kernel size +1? Maybe we do. So 0, 1, 2, 3 back at 0. Nice. 4, 5, 6, 7, 8, 9. Okay, so what happens if we put it all together now? So we use kernel step together with kernel size. So if you do 0, 1, 2, 3. But here we want to do 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. I wonder if we want to do kernel size +1, but and we have some cleanup to do here, but extremely blurry. Not a lot of performance loss, but what's happening here? Yeah. Okay, pretty damn good actually. Pretty damn good. 6. Here we start seeing. Here we start seeing some rough stuff. Is it rendered colors or opaque? We're working with scene textures, sample scene texture. Fuck, what did I call that one? Create scene texture. Point bilinear. What happens if we take bilinear here? Maybe we'll need to restart it. This, I wonder if we will be able to yeah, that's way better. We still see bleeding, but not as much. Yeah, we're gonna have to be a little bit okay. This actually looks beautiful, I think. Want to fix this, but I wonder what kind of result do we get if we skip distance weight. One, two. It's not that bad of a bleed. Oh, it is actually. But we only get bleeding on, let's see here, 1, 2, 3, on 3, and on 6. And on, okay, so it's when we do purely mip-mapped level to get the blur. Yo, what's up, DevSpios? Thank you so much for the raid, appreciate it. And you too, you too. And for all the new viewers over on this stream, we're trying to implement, one could say it's a depth of field effect or bokeh effect or whatever you want to call it. But we want to do it, we're working on a water shader, and we want to do it based on the depth of the water. So the further down an object is in water, the more we want to blur it. And I just want to make it look beautiful, but it's extremely hard. Master Agent Miyazaki, thank you so much for the follow, first of all. And Svensk, question mark? Ja. So I think we get a pretty good result up to till about Fuck, I hate this. Yeah, yeah, my accent usually gives me away. Having a real hard time getting rid of it, but Okay, the bleeding we see here, we definitely need to take care of that. And I'm also wondering about 1, 2, 3, or actually 1, 2, 3. Is there a difference between 2 and 3? I don't know. Let's do kernel step is easy. Kernel step divided by max kernel step size. And here we're gonna do kernel size modulus kernel step size plus kernel step let's just do plus kernel step is bigger than 0. So if it's 0, this one is 0. If it's 1, it's 1. Because that way we can do no blur, 1 blur, 2 blur, 3 blur, 4, 5, 6, 7, 8, 9. Fuck, if we go up to 9, it's starting to look extremely rough. Don't get rid of it, the accent that is. It's not a thick accent, just a slight accent. Maybe it's because I'm Swedish, but like the Swedish English accent is one of the ugliest one, I would say. Sumo31, thank you for the follow, appreciate it. Okay, here, if we keep it at a low blur level, so around 4, look at this. It looks pretty good. So things far down gets blurred a lot, and things close to the camera don't get blurred at all. Now we just need to fix this with the outlines as well. But before we do that, I'm still extremely annoyed at the... So 1, 2, 3. So as soon as our kernel size or kernel step, so like as soon as we start reading from a lower resolution texture, the scene color from a lower resolution texture, then we start seeing color bleed. But when we blur that one, we actually remove a bit of it. But I think that's just a 4, 5, 6. Yeah, look at this. 7, 8, 9. Yeah, and this is probably going to be one of the hardest things here, I think, to get rid of this. Well, I give you that, but growing up with hearing it, I must say it has a charm to it. that's what some people say. I'm not so sure though. Or like I guess every accent has some charm to it, right? I wonder if we want to do, if water depth is less than 0, water depth, minus pixel depth. Yeah, what the fuck, we just do continue here. Master Agent going to lurk, appreciate the lurk, got breakfast burgers to grill. What the hell? What kind of amazing breakfast are you gonna enjoy? Okay, I think this is the problem we're having. When we read, or actually this one, when we sample the scene depth here, we do it let's see here. Depth texture MIP maps Unity. Do we have homemade smash burgers? Damn, enjoy. I love smash burgers. Ooh, I wonder if we need to do this, or if we could get rid of it in some other way. Let's see if I can disable. Can I disable the outlines without breaking anything? Oh, it's so beautiful. Down here it's extremely beautiful. I love it. Best result yet, but apart from the bleeding, that is. But do we have any bleeding? It's not that much. Honestly, it's not too bad. It depends on, so 0, 1, 2, 3. Here it's at its worst, but if we blur, like we remove most of it by blurring an additional time. So compare 6, for instance, with 7, 8, 8, and then we have 9, 10. Yeah, I mean the blur effect, like it almost stops working as it is anyway at those levels, so I might skip it for now, because we're gonna have to redefine the full depth texture if we want to get rid of it entirely, because when we're comparing depths, we're comparing it to the, or actually are we? Maybe. One sec. Before I continue, I just need to run AFK real quick, so brb. Okay, backstory about that. I thought about this. I'm a little perplexed that we get bleeding here. Okay, so we're sampling from a downsampled texture, right? But we read the depth map from this value, so we shouldn't include this one unless we're not checking the correct one. So this one is above water level, so we shouldn't get this bleeding at all. It's weird, I would say. It's weird that we're getting it. I thought this one would take care of it. If water depth is less than 0, texel size, if depth is, so if pixel depth is smaller, it can't be this. Fuck it, let's return 1. Okay. I might know what's going on. Or do I? I wonder if it could be because maybe we should just check if depth here is, if depth is bigger than pixel depth. No. But this should be pretty much what we're checking. Or not. Or is it? Yeah, it is. I get it. So the downsampled image, yeah, we get the blur from the downsampled image here by default, so it's nothing in our code that has it. So it's when we downsample the textures, we get color bleed. And I don't know if there's anything we can do about it. Except for... No, it probably isn't. We're gonna have to be content with this small bleed we have going on here, and I'm gonna make an issue out of it, see if we can fix it some other time. Yeah, when we get to this much blur, we are pretty much, we're losing visual quality either way. So yeah, but what I want to do is, let's see here, 0, 1, 2, 3, 4. I think I want to fix this one, so we do kernel size plus kernel step bigger than 0. What we do here is we just do plus kernel step, which means that we're going to do, this one is going to go to 0, 1, 2, and then we get to 3, which means that this one is 0 and this one is 1. Then we get to 4, 5, 6. So at 6, this one is going to be 2 and this one is going to be 2, just to make it add an extra blur level per downsampling of the color texture we do. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this one is still rough as hell, but the performance is good. If I wonder, do we want to do, we might even want to do 2 times kernel step here. So yeah, that's what we want to do. And the bleeding up here is not as bad. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. I fucking love what I'm seeing here. Now we're just gonna have to make this work with the outlines as well, which might be... I wonder if it's gonna be easy or not. But this blur effect, love it. It's great, it's great, it's great. No complaints. Wow. Okay. I wonder if it's going to be hard to fix with the... We're going to do the final color blend as well. How does it look right now? Yeah, we don't even use it, so yeah. But let's see. So what do we want to do next? First of all, if depth is less than pixel depth, we can do the return here. We use water depth here. Water difference there. Now we do total weight. Yeah, so we want to change total weight to this one. Remove this one. I think this is the best solution yet. So I think we can, with great certainty so far, say that this solution we have now definitely is much better than that solution. So we can skip that one. Oh, I love how this looks. Okay, so hard part, getting the outlines to work as well. I think depth here, we're gonna have to read outline depth, which we do here. So depth, pixel depth, outline data, outline depth. We're gonna move these two here, and then we're gonna change this one. If depth is bigger than pixel depth, then we wanna do this. And then if outline depth is bigger than pixel depth, we want to do something else. Let's just see if we can enable outlines again. Okay, we're probably gonna have to restart it, so let's do it. Okay, so we want to do the exact same thing here, but we want to do it with outline depth. Water depth, here we use depth, we use this one. So we're going to have to do both of these. This one utilizes scene water depth. Yeah, we want to use outline water depth here. For this one, water depth difference, yeah, we want to use that one. Distance weight, this one we can actually use the same. So let's move this one out here. Okay, so we're gonna do float outline water depth is equal to outline depth minus pixel depth, I guess. Float outline water depth difference abs outline water depth minus scene water depth. And then we do float base weight is equal to saturate inverse lerp scene water depth. I think we want to use outline water depth here. Float weight 1 minus saturate inverse lerp 0 water blur margin dot x, and water depth difference here we want to do outline water depth difference. Total weight we can just copy. And then we do outline plus equals to, yeah, we need to fix outline up here as well. So outline is not going to be 0, it's going to be sample, we're going to do outlines yeah, this might be, we might want to do this later on actually, when we have figured out this. That is true. Derek, Robin, use my donation to get some music that you can use for this stream. Maybe I should look into that one again. But isn't it nice to be able to listen to your own music at the same time? I wonder about this one. Maybe we want to do pixel outline data. We use it here. Pixel outline depth. For now, let's do it like this. Pixel outline data. Float for, or actually pixel outline data is equal to do it like this, and then here we want to sample again. Yeah, we're pretty much gonna do this, but outline count, total weight. In fact, don't we sample this one already? Oh, yeah, we do. Outline data here. So we can just do outline data dot R. And then we do color is equal to and outline equal to outline count. Maybe this. Oh yeah. $323. Are we doing something wrong here? This one is okay. This one is okay. Total weight times outline data R. What am I missing here? Unexpected integer constant at 3.8. What? Mm-hmm. Okay. Mm. Return blend source outline. Let's do okay, we're getting a lot more bleed here, which is very unfortunate. Let's see here. One works, two works, three. That's when we start seeing stuff like this. But this looks beautiful. I think when it comes to the outlines above or below sea level, I think, yeah, we have this though, but we shouldn't be seeing this much blur up here, I don't think. One, two, three. Okay, so as soon as we start reading from the wrong outline, or as soon as we start reading from a downsampled outline texture, that's when we start seeing shit like this. Unfortunate. Outlines texture generation. Point bilinear. It's a little bit better, but we're still getting blur when we don't want blur. That's not good. 1, 2, 3, and we lose it as well. Yeah, pretty sure we don't want to use scene water depth here, but rather outline water depth. But still. We're also losing a lot of performance when including the outlines, which I find to be quite weird. Is it just the... It's not just the additional sampling here. Because we had that one previously. Okay, so if outline depth is bigger than pixel depth, then we want to do this. One sec. Yeah, okay, this one we can probably do. Why? Why? And why are we losing so much performance? It's crazy. 6. Okay. We're losing. Yeah, we might want to be. Yeah, we might want to chill a bit with. Which one is it? I think it's. this one, so 2 times. So worst case scenario, we have 3. Let's see here. If we go to 10, we get 1 here. No. We get 3 here, 1 here. Or actually, yeah, 3 here, 1 here. So we have 1. So we have 7. Yeah, that's rough. Yo, what's up, Diligence Humility? Okay, so the only question that remains... Oh, 1 sec. One, 2, 3. So as soon as we jump up in, or we go lower in texture or MIP level, we lose the outlines. Why is that? Outline data. Yeah, I think it's because, yeah, we sample with this one. Linear eye depth. I want... I think we want to use this one. Yeah, because we're using a unlinear value when we pack it, so I don't think... Linear 0.1 depth. Yeah, let's do this. Outlines, texture, generate. No. Outlines for texture. So when we do pixel depth max here, this one is non-linear 0 to 1. So we pretty much just want to do not linear eye depth, but let's do it here actually. So this one. And I guess we want to involve C buffer params. Like this, and then we use outline depth. Here we just do B, but then we compare it to pixel depth, which is non-linear outline depth. So we need to do I always forget this one. Projection params, I think it is we want. So let's do inverse lerp, projection params, y z, and then pixel depth. Let's do saturate just to be sure. And we want to do the same thing here. Okay, let's just see if this gives us roughly what we want. No, it doesn't. Is it better though? I don't think so. So as soon as we read from the downsampled outlines texture, we get this problem. But why? Fuck, I wonder if we want to do 0 here. So much. It's looking pretty damn good down here, even with this one. This is pretty rough. I guess what we want to do here is we want to do I'm going to do 0 there. And outline depth is bigger than pixel depth. And pixel outline depth. Okay, what the fuck is going on here? No, pixel outline depth is... Okay, we didn't... I screwed it up previously. What the hell is going on down here now? What have I done? This check we want to have here, but not right now. There we go. Okay, so the problem is... Now we want to do it like this. Let's see here. Let's pixel outline data 0. Just trying something here. Float pixel outline depth 0. So this one we want to test here, but we want to read from... What the fuck? Are you serious? Okay, so that's not... Something else has been done with this one as well. Do I want to pixel outline depth? Yeah, maybe we want to check this as well. Pixel outline depth 0. Let's just take this one, put it here, and oops. Call this one pixel outline depth 0, 0, 0. Otherwise this. That is incredibly weird. Okay, so it's not this check. So what is it? Something. I hate the way the outlines bleed. Crazy bleed. But anyway, I need to fix this. So if we set this one to 0, then it works, or then we screw up the underwater outlines, but we fix the overwater outlines. So what's the deal? Is it this one? starting to think that this depth here doesn't get transferred correctly, pretty much. So I wonder if we want to do only do this if the outline depth is bigger than pixel depth. Now I don't get this. The only thing we should need to read here is the pixel itself. So we should be able to do this with just like we did. 0, and we do a yeah, I'm not I don't get why this wouldn't work. So float for pixel outline data 0. Exactly what we did previously. Did I do something wrong here? Outline data 2, we do data 0, data 0. Pixel scene depth. No. And pixel outline depth 0. Oh, we actually had it commented out here. Oh, my bad. But then doing this simple comparison should fucking fix it. It shouldn't fix the bleeding, but it should fix the removal of some pixels, I would say. Or actually, one sec. Yes. Fuck, do we actually want to do 0 here? Oh, not on this one, but on outline, pixel outline data 0. Is that it? Yes. No. What the fuck? How could it not be? Because this one, there we go. I'm pretty sure this should be it then. Yes. Now we only have the bleeding to keep track of, and the bleeding is very rough. also want to fix this, so we're actually gonna do, instead of doing pixel outline data 0 like this, we want to do pixel depth, pixel scene depth. Or we want to read pixel outline data at 0, so like this. And then we want to check pixel outline depth here. We want to do if pixel outline data r is bigger than 0, and this one, yeah, here we want to do if pixel outline depth is bigger than or less than pixel depth, then we want to redo this stuff. But we want to redo it with kernel step here. Like this, I think. And then here we do our it's very rough, but I think we have to do it like this. 302. How is this? Are you fucking kidding me? If pixel outline depth. There we go. Now we have the bleeding left as well, but before we do that, I just need to run FK real quick. So 1 sec. back. Sorry about that. This did fix it, right? Yeah, we still have the bleeding, but it should be okay. I think this approach is definitely much better. I wonder though how to handle the bleeding. I'm wondering if yeah, the bleeding is in the MIPS. So when we read the value, we're gonna get this bleeding either way. We're gonna have to work with the... We're gonna have to work with weights, definitely. We're gonna have to switch. We're gonna have to have different weights for the outlines. So water blur, water depth bounds. That's just a base weight. We want to change this weight. Ooh, water blur margin X. Yeah, maybe if we go with Y here. And we do 1, 2, 3, 4, 5, 6. What do we want to go? -5. Then we lose it here. Go 3. One sec. Distance weight we don't care about. So outline water depth difference. Outline water depth. Scene water depth. Something like 5. But then when we go here, we lose a lot of the outlines. But. No, I don't get it. We shouldn't be getting bleeds here if This one should be 0 if we're close to this one. The depth between this one and this one, yeah, okay, we're not doing linear, or are we? It stems from the fact that we're not doing linear. Let's see here, outlines for texture. Let's try linear 0,1 depth instead. So we do pixel depth. Let's see. Let's do B, B, and then we take this one and we do, not really, but pixel depth 0,1, saturate, inverse lerp, what is it, projection, params dot y, project params dot z, and pixel depth. And we compare with this one. Doesn't seem to work. Yeah, because we're not doing it here. Linear outline depth. We want to do outline data. So the idea is that in here we do linear 0,1 depth. We fix this one here, so we don't need to do pixel outline depth. Here we just do B. And same here. I don't think we're getting as much bleed. 10. But we're fucking this up. Okay, why is that? Welcome back, Diligence Humility. We're moving forward. We're moving forward. Maybe this one is the best one yet. But are we still getting bleeds here? Yes, we are, but not too much. -5. I was still getting bleeds. That's weird. Diligence Humility. I have a problem myself since 2 days now. Making my own camera in Godot. Trying to do dynamic dead zones each for X and Y. 2D platformer. It's a pain. Yeah, I reckon. Have you tried ChatGPT? And what exactly do you mean by dynamic dead zones? Where are we getting? Let's see here. Here we go, maybe. Okay, I think we have it. Or do we? How about the bleed? We get a tiny little bleed here, but I don't think it's not that bad. It's definitely okay, I think. Best one yet, at least. Although, why the hell are we getting... Nah, we should be getting more blur on the outlines here, I think. Diligence, humility. For the X, there is look ahead, so when moving to the left, the character is on the right side of the... Oh, yeah. So I want the dead zone to move with the character for X only, like old school Mario. I get it. Okay, so this one here, scene water depth. Fuck me. Linear eye depth, I think. I think we want to make this one work. Let's see, linear eye depth 0, 1. Basically what I'm gonna do is we're gonna linear eye depth. I want to change this one to pixel scene depth. Okay, so linear eye depth, let's replace this one with linear 0, 1 depth. And then we replace, or we take this one and we do saturate, inverse lerp, projection params dot y, projection params dot z. So we just work with linear depth at all time. What are we looking at then? depth. We're getting a problem here though. Fuck, is this not the correct way to do it? No, I'm pretty sure. Pretty sure. Linear 0-1 depth. But Yeah, I think it's this one I'm the most worried about. I wonder if... I wonder if this is... So pretty much want to convert this from iSpace, I guess, or we want to interpolate it from iSpace down to 0, 1. I don't know. Get depth between 0 and 1 from vertex position. But can we get... Fuck, I'm already... Look at this one. Diligence, humility, I'd say port it to Godot. Port what? The project, nah. I don't even know if I can do everything. Ooh, one sec. Is this what I want? I don't know. It's worth a try. So pixel depth is equal to this. Right, and then we do pixel depth is equal to fuck, is it actually this we want to do? Maybe. So if we just do times equal to projection params dot w. No. Okay. this works so fucking good. I love it. It's insane how good it works. But the problem being... the outlines. Jesus, it works so good, so good, so good, so good. I don't think ChatGPT could tell me that. Maybe. But as soon as we add the outlines to this, we get chaos. Or do we? Okay, we don't do anything with the outlines right now. Oh, it looks so good. If we could just fix the outlines here as well. So what do we do? Outline depth is bigger than pixel depth. Outline depth, we just do outline data B, which I think is wrong. It's definitely wrong right now. Pixel depth. Pixel outline depth. Thank you, Diligence Humility. I appreciate it. One sec. Okay. I might know what the problem is. And I'm wondering about... kernel step, kernel size. Let's just return color again. We want to do the exact same thing, but for the outlines. But then we need to figure out how to handle outline depth, bigger than pixel depth, outline data R. Yeah, we need to figure out how to handle this one. Like, I'm a little bit afraid of how. So when we downsample the texture, how we store the depth value in the outline texture. But maybe what if we store it as what if we store it as saturate, inverse lerp, projection, projection params dot y, projection params dot z, pixel depth max. And then we do float outline, this one. And here we do if outline is bigger than 0, then we store it as this one, otherwise just 0, I think. And then we jump back here. So when we read pixel outline depth, we read G, but we also do lerp, projection params dot y, projection params dot z. And we do the same here. And then we do the same here. And then we work with it. It's just inverse lerp. Oh yeah. I'm a little bit like, I worry about what actually happens during the downsampling. And I wonder if that destroys the data we have, and that's why we're not getting the best result for the outlines. Fuck. Did I forget to do something? Yeah, now we don't do anything with the outlines. Pixel depth, outline depth. It's been a pixel depth. Pixel outline data R. GG. Actually, do I want to avoid... How did I manage to screw it up this much? Okay, so now we don't do anything here. Okay, okay. So this doesn't work. Projection, params. I'm doing it the correct way. Y, near plane, Z, far plane. 1 divided by far plane. Is that what we want to do instead? Pixel depth max is... Oh, 1 sec. Yeah, we just sample it. Yes, we might want to do... Do we want to do this here? But not... We do linear eye depth. Okay, now we're blurring it at least. Looks okay from a distance. Do we have bleeding? Yes, we have a little bit of a bleeding, but I don't think... I don't know if we can improve this. 0.0. Like, I don't know if... Oh, what the fuck? Okay, maybe. Okay, we don't have any bleeding now, that's good. But we don't get any... Actually, do we? Okay, maybe this is it. But yeah, maybe this is it. Maybe this is it. I'm pretty sure this is the best solution we have yet. We have pretty much no bleeding. And we blur the outlines a tiny bit. We blur them more. I think this is it. Although, not a very big fan of what we get here. Diligence, you are the bass hunter slash base hunter of games. You could be the outline hunter. Yeah, outline hunter is probably a pretty good title, because it feels like that's the only thing I've been doing as of late. But I think this is pretty much it. I don't know about this though. Yeah, this is probably as good as it gets. But how does... I guess it looks okay. Diligence, humility, try and add the water also and see how it looks. Yeah, we're probably gonna save that to tomorrow. We're gonna need to do some blending there. And what's up, Scafer? Interesting, why is the performance so bad with the large kernel size? It's like the larger the kernel size, the more pixels we iterate over when we do the blurring. We have optimized it quite a lot, so the blurring we see here should actually be a kernel size of, what would be the equivalent? I don't know, 20 times 20 maybe, but we have optimized it so that we get the same, roughly the same visuals with a kernel size that is just 8 times 8, I think. I'm not entirely sure about the outline just yet. We get this weird shadowing here, but if we don't look at it that close, it's okay. Yeah, I think I'm gonna be happy with it for now, and maybe we can improve upon it later on. We're probably just gonna go with a blurring of 5-ish, maybe 6-ish. This is probably the most we're gonna go with, and I don't even know how. Chris, by the way, thank you for the follow, appreciate it. This is definitely the best result we've gotten so far. even though it comes with a few not so good things, but maybe if outline data, what do we have? Pixel outline data dot r is bigger than 0.0. I'm wondering about these shadows. Extremely weird. I want to try and do this again. Two, three. Yeah, what the fuck? Why, oh why? Nah, I'm not gonna lie, I'm extremely bothered by the shadowing we get here. Like, why are we getting it? it 100% has to do with the outlines. Okay, we get them when we output 0 if we don't have an outline. I wonder what happens if we output something depth. Pixel depth. Okay, I fucking think we got it. Unless we have bleeding here now. Which we do, but it's not too bad. It's a lip. Fuck. Okay, but we're close, we're close. Extremely close. Mm-hmm. Mm. So much work for an effect that is probably not. I don't know how much we're going to use it or if we're going to use it. We're basically going to have, like, the blurring we get here is probably just going to be relevant when this is probably the best one we have yet. Yeah, I'm definitely happy with this one. But we're gonna clean it up, add the watercolor tomorrow, because unfortunately I don't have much more. I don't have more time right now. I gotta run. But damn, beautiful. It's definitely at acceptable right now. So yeah, we're gonna clean it up, add watercolor tomorrow, and then we are finally gonna move on to better stuff. But yes, beautiful. Thank you so much for watching, everybody. Very much appreciated. Hopefully I will see you tomorrow. Have a great rest of the day. Peace.